Hello everyone, my name is Schwaighofer. I'm really excited for the opportunity to be giving this talk to you today as part of Conflang 21. So part of my job at university is teaching a systems programming course. We have about 180 students each year and this talk is about my attempts of further automating that course and teaching that course while also learning more about NICs. So this is going to be an experience report. I don't have any deep insights or great solutions that I want to share, but I want to talk about a number of specific problems that I ran into because I think they are worth talking about. Before we talk about the specific problems that I encountered, I want to take a step back and first look at the starting point and basically the specific things that I have been working on. We do provide a VM for students to download and work on assignments so that there is some common defined environment. At the bottom of the page you can see the first assignment. We give the tests and the assignments that were handed in. We pass them on to tutors that we have for this course, luckily. And so the tutors have to use the same VM as well, otherwise they wouldn't get the same compiler warnings, for example. And now I want to show you some of the improvements that I've been working on. So the first thing here is this form. While students are still working on their stuff, or every time that they try to submit something, they already get feedback for it. And this would turn up things like compiler warnings, maybe run a test case or two. Now another thing that I did is write some NICs code that produces an output where all of the tests have been run for all of the submissions, and eventually the idea behind it is to have some CI-like workflow. The last thing that I want to show here is about the virtual machine. This is the configuration that's part of that image. As an alternative to downloading the image we provide, they could actually just start from the same description and build that same image. Okay, now I want to get into the specific issues that I ran into while I was working on this stuff. And if I now execute this thing, we can see that it fails because the reference and the student output don't match up. And I actually want my code to do this for 50 students. You need this to not fail so that it proceeds and so that eventually it can give you nice outputs, right? So inside the bash file, we just say, oh, well, ignore an error here if it occurs. It would be nice to deal with that failure programmatically. Now the next topic that I want to look at is build logs. We try to build a C program, and if we do that, we can see that it fails because this example file that we provide here is broken. And what we want to get at now as the output of this is we would like the log. We want to get at the log programmatically somehow. So you can do output redirection. Then you can also do the same thing with the T command, which is nice because it gives you the output on NICs log, and it also writes it to a file for you so that you can use it in other derivations that depend on this one. Now another thing that was an issue for me was timeouts. Well, the way I dealt with that issue is by adding a timeout command here with a timeout of, let's say, 5 seconds. And now if we invoke this, it should be done after 5 seconds. Yeah, I'm wondering if something like this would be possible on a derivation level, and what that might look like. Now, another topic that I had trouble with was the topic of personal data. One issue is that anything that we build in NICs ends up in the NICs store. You can do garbage collection on your store, and then everything that's not referenced by anything will be cleaned up. But I don't really know of a good way to say, okay, now I want to get rid of all of the student data that I have in my NICs store, if you get it in there. Okay, so coming from these examples, the broader point that I wanted to raise, finishing up now, is what is the purpose of a build tool? And the obvious answer that comes to my mind is, well, it's for building outputs, it's for building artifacts, but I do think that auxiliary outputs like logs, warnings, performance metrics, and the ability to exercise control over build step, they are equally as important. But I do wonder if NICs could do something to better support those use cases without compromising the overall design. So this is the end of my talk. Thank you very much for listening. I do look forward to discussing this. I would be also very happy if you would send me an email, and thank you very much for the opportunity.